Hello everyone, welcome back to our 7th video in which we transform the graphs of y equals sine x and y equals cosine x. Let's revise a few terms before we do that. Here we have the graph of y equals sine x. It has a period of 2 pi or 360 degrees. That's the length of the cycle, and this dimension we call the amplitude, which is 1. And today we're going to be calling this line in the middle, so to speak, is the principal axis. Okay. Well, in order to transform the function, we need to revise a little bit of graph transformations and also the idea of a parameter. Let's take a simple example of y equals mx plus c. M is a parameter which affects the gradient. In fact, it equals the gradient. And c is a parameter which affects the y-intercept, 0c. Okay, we all know that. Those are parameters. X and y are variables, m and c are parameters. So the question we're aiming for ultimately is, when we have a trig function like this, then what does a, b, c and d do to the graph of the function? How does it transform this graph? Well, before we answer that, we're going to revise what we did last year, because we did graph transformations. And the good news is what we learned last year directly applies to what we are doing this year. So let's just revise graph transformations. I made a crazy looking graph like this, a bit of a zigzag. And I have the formula here, y equals p f q x minus a plus b. Let's take the b first of all. What do you think it does? Have a think. It's altering this number right here. That's a vertical translation. If I make a negative, the graph goes down from its original position. Let's look at this one here, p. What does that do? That's a vertical stretch. Notice here the x values do not change, the y values do. And the bigger the value of p, the further away we go from the x-axis. Okay, now those are two parameters outside the brackets. Let's look inside. The parameter a, if I move that in the positive direction, the graph moves in the positive direction. Go back to the beginning. Now if I move it in the negative direction, the graph moves in the negative direction. Now the last one is q. That's also inside the brackets. And it's kind of a tricky one, because the bigger the value of q, the closer the graph is to the y-axis. In this transformation, the y values stay unchanged, the x values are the ones that change. And if I make q less than 1, it moves further away from the y-axis. Just by chance, this intercept here is 5. If I make q2 you can see that that 0.5 has moved to approximately 2.5. Now those of you that are really watching will have noticed I've put the answers here already. They're all here. That's what those parameters do. Okay, so let's look at the results. What's important is that we don't memorize letters because they could use different letters in the exam. There's a quick way to remember these. If you look at the parameters which were in the brackets and the ones that were outside, well, the ones that were inside are Q and A, and the ones that are outside are P and B. The ones inside affected the horizontal. The ones outside affected the vertical. And you can see that horizontal, H comes before V in the alphabet, I comes before O. That's just a little trick to help you remember. And be very careful on this one. The scale factor is 1 over Q. Okay, now let's answer the question we're looking for, and that is what happens when we have a trig function being transformed. Well, the good news is it's just the same. So here we have D outside the brackets. Outside means vertical. So like before, it's a vertical translation. And here we have A outside the brackets. Can you guess what that is? It's a vertical stretch. And here we have C inside the brackets. I'm sure you've guessed that's the horizontal translation. And then we have B inside the brackets. Now let's let B equal 2. Okay. At this moment, if you look very carefully right here, that was really badly drawn. You may see that in one cycle of the original function in black, we have 2 cycles of the transformed function. Therefore, the period of the transformed function is not 2 pi, but 1 pi. Okay, so let's summarize these results. We have the vertical translation by D and the vertical stretch scale factor A. Okay, let's just do our little table in, out. What's inside the brackets? B, C. What's outside the brackets? A, D. Horizontal, vertical. But we can say a little bit more than this, because if the vertical translation is D, then there's an equation for the principal axis is now y equals d. And the vertical stretch gives us a formula for the amplitude, which is the absolute value of A. And this one gives us an equation for the period, because the period, which was 2 pi, has been scaled by a factor of 1 over b. Okay. Now, when I taught in Egypt, I had a joke with my students when we were trying to remember this. A is for amplitude. Okay, we've got that. And because in Arabic the sound P doesn't come easily, it sounds a bit more like B. They used to say B is for period. But be careful, B is not the period. It gives you the way to work out the period. It's 2 pi divided by B. If you say the period is B, you won't get the right answer. Now in the next video, we will talk about these formulas which are also true about the transformed sine or cosine function. And here is a nice photo of some skew lines I saw in the winter skies above Abingdon the other day. Thanks for watching.